everyone, today we will be solving the question Xorred that came in CodeChef contest and sir difficulty rating of 2830. In this question, you will be given an array B of length m and you need to find the number of sub-arrays so that the sub-array and as well as Xorred both are equal. Now, a single number would always be a sub-array because it have always equal Xorred as well as equal and so it will always be a magical sub-array. And we need to calculate those sub-arrays. So how could we find that? So let me show the intuition for this question.
You will be given n as well as an integer that will be representing the array, and you have to find the number of sub arrays with equal XOR and how would we find that? We know that if we are having a number x and the x and y will be always be less than or equals to x. Why this? Because and operation always decrease or make the value remain same. So it may decrease or equal. It never increases the value. So let's say we are having an array with 7 indices 1, 2, 3, 4, 5, 6, 7. If you want to find the dropping points for x, let's say at index 6 we are having the element x and x over here, let's say a5, a4, a3, a2, a1. Now the and of this two indices is x only, and this three indices is also x, because we know that the and operation may decrease the value or it remains same. So for 4, 5, 6 the and operation is x, but at index 3 it decreases to some value, then it remain consistent up to index 2. Let's say over here it becomes a value y, and over it again it decreases to a value z. So we get that if we are doing a and from index 6, if I want to find total number of sub arrays, that index 6 is contributing a different and. Like if I'm including the index 6, then the and operation of 6 5 is x, and operation of 6 5 4 is x only. After that, doing a and with index 3, it becomes y. That is the and of 3 4 5 6 3 y. Again it becomes y only, and after that it becomes z. So we over here we can notice that for some indices the and is same. So I know the and value for 4 5 6 index. Now if I try to find the XOR x for 4 5 6, let's say I'm storing a prefix XOR. What this prefix XOR is storing is the prefix XOR calculation for all the indices 1 2 3 4 5 6 7. Like one is containing the prefix of 1, then it will be containing 1 2, so on and so forth. And I want to find the XOR including index 6 with a result of x only. So I know the prefix XOR for index 6. Yeah, using the prefix XOR array. Now, which index should I remove so that the resultant bit becomes x? That I want, because I know the and is x. To make the subarray magical, it should also have the XOR as x. So, prefix XOR at index 7, I know, let's say, has some value, and I want to do a XOR. This part I want to remove. Like at index 6, if I am having 1 2 3 4 5 6 XOR, now I want to remove some index so that the XOR becomes x. How can I find this subarray so that XOR becomes x? And I want the XOR from index 4 to 6 only, because the and from 4 to 6 is x at everywhere. Like if I am taking 4 5 6, The index for 6 is x. Index 5, 6, the and is x. Again, index 4, 5, 6, the and is x. So for these three indices, the and is always x. So if I want to include index 6, so what part should I remove for this or like the prefix or for index 6? I know that. So what part should I remove so that it becomes x? So z will be equals to x or prefix XOR of sixth index. So this thing I need to calculate from the map. Let's say I'm storing it in a map. I want to know with a XOR of z how many indices are there in between 4, 5, 6, excluding 6. Why excluding 6? Because I want to include this index 6. So I cannot exclude it. If I'm performing a XOR for index 6, so all the values will get removed. That thing I don't want. I want to take index 6 and remove any of the indices for either 5. So from 4 to 6, I want the indices with XOR this set. Can I do that? Yes, using a map we can find those indices from 4 to 6. We can find those indices. So the dropping point was 4 over there. Then again from 4 to, I know the dropping point. Let's say it was 2. So from 2 to 4, the XOR was y only. Not the XOR, it was AND. So the AND was y only. So I know the AND. So how many indices from 2 to 4 are there with a XOR of some, like I want the AND to be y. So that is the resultant for XOR. And prefix of 4 would be something. And let's say I want W. So I want the W. So prefix of 4 XOR y. I want to find the indices from 2 to 4 with this value w, and I don't want to include the fourth index, like from 2 3 I could say, like excluding the fourth index, including the second index. So this value we can find. So here the key point is dropping point. So if I know the dropping point for 6, how could I find the dropping point for 7? So we know that by doing a AND, the value could decrease, but it will be containing. Like if I am doing the AND of 7 and 6, at this place it will be containing the ones that this particular element have. That is at 6. It will be containing all the ones in the binary form that this particular element have. So the dropping points will remain same for this element. So if I'm considering 6 as one of the dropping points, so other dropping points will be the dropping points for element 6. So this will be the dropping point for element 7. So we can find the dropping points using this trick for each and every indices. And then again we need to consider only the dropping points to get those sub arrays. So let me show the code and it will be more clear.
What I've done in this code is first taken an input n and then initialize the answer as 0. Now I've taken two DQs, that is W index Q, previous and current. Now I've taken an input each error of I, and X is containing the prefix or for all the elements from the 0th index up to the ith index. And then I'm pushing at what index I'm getting a XOR X. So that is I. So I push that, and prefix for I, that the at ith index what is the prefix of. So that is X, which I have assigned. Now for each index I'll be traversing. Now for any index, if I'm trying to calculating the dropping points, if I'm standing at the first index, so it will not have any dropping points, so it will be a dropping point 0. Why it is 0? Because I have one based indexing. So if I'm standing at index 1, so 1 itself would be a sub-array which is magical also. So I have dropped at index 0, which is basically non-valid, but we have taken as one of the dropping points as 0, which we will not be using that. Now current, we have pushed I. Why I? Because for I plus 1 index, we are assuming that I would be a dropping point. So current is storing the dropping points for I plus 1th index. So I have considered I one of the dropping points. Now, why I have pushed I in the previous? Because previous is containing all the dropping points for index I itself. But what's the starting point? So it is I because we are including I up to 0. Using those dropping points, we'll be calculating those sub arrays. Now, we are standing at index I, which is the current index now. So if we are standing at j equals to 1, so previous of j minus 1 would be I itself because we have pushed in the front I. So now it is I itself. So I'm standing at current index and what my dropping point. So I have to exclude this dropping point. So I have the consistent and from current index to dropping point plus 1. So this is my range for the consistent and doing an AND operation with error of current index. So if it is not equals to AND, it means it is getting dropped. If it is getting dropped, so it would be a dropping point. So I'm storing and for the I plus 1th index, so it would be a dropping point. For I plus 1th index, we will be using that. Like the previous is storing all the dropping points now. So I'm using that for ith index. So I'm just removing some dropping points so that the I plus 1th index would have lesser dropping points to consider, which will contribute to a time complexity. So that's why I'm checking that. So I'm modifying my dropping points. After that, I'm doing an AND operation with the current index, which are the dropping points. So I have started with current index. Now for the current index, I got and as this. So from current index to dropping point plus 1, I have the same and which is this A and DD. Now I want A and DD. From dropping point to current index, this is the and for each and every index considering the current index. Like if I store that 876 87654. So let's say the current index I'm standing at 8 and 4 is the dropping point. So I'm doing an AND operation with current index because I have to consider this index. So what my AND would be? So this is A and D. Now from 8 to 4, for every index I'm getting the same AND, which is A and DD. So what these OR would be for from 8 to 5? Can I get the same AND? Can I get the same XOR which I got as A and DD? So that's why I'm calculating Z equals to A and DD XOR pref of I. So what part I should exclude from pref of I, that is the prefix XOR up to index I8. For this example, the prefix is the prefix XOR up to index 8. So what part I should exclude to get a XOR of A and DD? So I got Z. So Z I should exclude to get a XOR of A and DD. So I'm checking that my map has contained Z or not. If it is containing, it means I need to find the indices that it is containing from 5, 6, 7, 8. Is it containing some indices? So it's a lower bound for current of index minus the dropping point. Why this lower bound? Because I want to exclude. So whatever index I'll be getting from this, so we are excluding that part. That is Z. We have to exclude that part to get a XOR of A and DD. So I could exclude 4 for sure because 4 is a dropping point. We are not taking that. So if I got 4 in this MP of Z, so if I got 4, I'll be removing that. But if I got 8, I cannot remove that because 8 is, we have to include it. Because we are considering if I include 8, what the sub arrays that I could have. So I cannot exclude 8, but I can exclude 4, 5, 6, 7, up to 4 to 7. So that's why I'm taking a lower bound because I can exclude the current index, but I cannot exclude the dropping point. So that's why is the lower bound for current index minus the lower bound of the dropping point. So whatever indices I'm getting for this Z XOR, which will be which we if we remove that. it will be A and DD XOR. That's we are adding in our answer. And then again our pref will be changed, that because our dropping point has been changed, so we are again assigning that, and after that we are printing that. So that's it. I hope you like it. Thank you for watching.